Our next learning unit covers a tool called a HAZOP, which stands for Hazard and Operability Process. And there is not a chapter dedicated to this in the text that we are using, and therefore there's a few videos for you to take a look at that will bolster the material that you learn here in this learning unit. So our objectives are for you to understand the purpose and process in which a HAZOP is used, as well as the importance to certain industries. By far the chemical and nuclear industry use HAZOPs. And then you'll be able to practice using the tool for your homework assignment. And so a hazard and operability study is a systematic approach using subject matter experts, so you may be one of the subject matter experts, to determine potential problems by reviewing safety of designs, existing processes, and operations. And so this differs significantly when compared to a job hazard analysis, because here we're looking at processes, where with the job hazard analysis we're looking at jobs or tasks, right? So this has a higher level, more global approach. It's used in chemical industries, pharmaceuticals, oil and gas, and definitely the nuclear industries. And another thing that makes the HAZOP stand out is it uses these guide words to help you get to where you need to go. So HAZOP again takes a look at processes, and it's a method that's recognized in OSHA's Process Safety Management Standard. And it's a form of risk assessment that's applied to complex processes. And for me, I consider every process fairly complex, because when you break it down into subparts, there tends to be areas in which it's really salient what the hazards can be, and other areas in which it's hidden beneath. So it's definitely suitable for assessing hazards in facilities, equipment, and processes, but not suitable for assessing tasks. So there's 3 different levels in which you can take a look at this. You can use this in the design phase, which makes sure that the capabilities of the system meet the user specification, and you can identify weaknesses or threats, and then put countermeasures in place. You can take a look at the physical environment, and so this is where I've used a HAZOP before, is to take a look at where the environment is situated, or where the facility is situated within the environment, what happens upstream and downstream, whether the facility within itself is supported by services, and whether the facility is self-contained or not self-contained. And then the operational and procedural controls, this is where it's used really quite predominantly, is to take a look at the engineering controls, the sequence of events, and the procedures to make sure that they don't introduce any undue risk or likelihood of a unfavorable event occurring. And so we can think about this in different modes, and that's where it becomes quite complicated, because you have startup, standby, normal operation, steady use, unsteady state, shutdown, and emergency shutdown. And so the HAZOP can be used in all these different areas, and really it's a structured brainstorming methodology used with subject matter experts. So you may be a facilitator, but chances are you're going to be one of the subject matter experts, and that's where my role has come into play when using a HAZOP. So if you haven't used one of these before, or have the ability to be on a team, then it it helps to just do a comparison to something that you're probably really familiar with, such as a risk assessment. So risk assessment is used for identifying risks and determining the severities. A HAZOP is more time-consuming because it involves a rigorous review of designs. And so you have engineering drawings in front of you when you're determining the HAZOP. And so there's an example here of a HAZOP that was conducted, so you can take a look at not only the template, but just what the regular outcomes would be. So you can conduct a HAZOP in 4 phases. However, phase 3 is really large. It tends to be broken down and take the longest. And so we'll take a look at each one of these phases to help you understand the HAZOP process and where it may be important for you in the industry in which you're currently supporting, or maybe you can integrate it into something else that you're currently doing by using it as a different perspective. And so in the beginning of any type of process or analytical procedure, we really need to be able to identify what our scope is. Because if we don't identify our scope, we can go off scope and take a look at too much, and then we're really not providing any benefit to everybody. So during the preparation phase, we assemble a team, and that's again a team of good subject matter experts who can work well together. And then we set up some timelines and a format to make sure that we're all on the same page when we're recording our events. Our examination phase is it is the largest phase, and that is where we really begin to identify the different elements and parts in which we're going to take a closer look and break them down into something that the HAZOP uses the word nodes. And so, for example, if you had a step in which an operator opened a valve, there can be different nodes in there where they maybe check a gauge, lockout, tag out, open the valve, and then do some other checks, right? So we have these subcategories that take place. So during the preparation phase, we definitely pull these process, piping, and instrumentation diagrams, and they're called P&IDs. And they help us identify the important processes in the operation. And then when we take a look at the drawings, that definitely helps us understand the interconnection between the process and the equipment and the controls and the displays within the physical plant itself. During our preparation phase, we make sure that we're all using the same type of template, and we can choose these HAZOP guide words. And this is like this foundation to what HAZOP really has to do, is it uses the identifying words that stimulate imaginative thinking to focus our study and elicit decisions. And so during our HAZOP, it's really a brainstorming session with subject matter experts. And so if you've ever been involved in a emergency response exercise in which everybody's sitting in the room and you're doing a tabletop exercise and you're brainstorming what could happen, this is very similar. So our guide words help us define some parameters and all speak the same language. And so there are words like no, none, more, less, as well as, part of, reverse, other than, early, late, before, after, faster, or slower. And so we understand what the meaning is, but they help us define these parameters so we can determine when deviations from the best phase, the best operating phase, has occurred. And we use these because it helps us with our language. And so they are the core of the HAZOP. And so when is there no water supplied to a system? When is there too much water supplied to a system? When is the water being supplied at a slower rate, or when is it being applied at a quicker rate? So you're probably wondering what a HAZOP looks like, and here's an example. So we have our deviation, which is our temperature is less, and it causes fuel gases to be superheated out of the operational efficiency, and it causes us to have a failure or a loss of control as a consequence. And so the gas temperature may drop below the dew point and reduce or increase the likelihood that hydrocarbons are going to be put into our system. And so our safeguard is we have an alarm, and an operator must take action to ensure that things are not being superheated. And this is an example of how we use these guide words to help us figure out how there's deviations to the operation. And again, this is a brainstorming type of session with our subject matter experts. And so this example is looking at a cleaning operation, and so detergent is added too early, detergent is added too late, there's not enough detergent, there's too much detergent, no detergent is added at all, or the detergent is contaminated, right? And so I think now you could kind of understand these guide words, but the best way to use a system, or the best way to learn a system, is to use a system. And so we'll do that in our homework.